we have run our program. We know it works, and now we're going to do the tracing chart for it. So with our tracing chart, all we need to do is take this and then take the values that we have here and then unassemble it just to make sure. So we're going to take all this, and we're not going to do the g is equal to 100. So we paste all this inside of here, and then we are going to press enter. Now from here, we're going to do what we have done a lot previously. So looking back here, what we're going to want to do is R dash R. So we'll do R, press enter, that's going to reset. But actually, I guess we don't need to do that because we already have everything that we need right here, and we can just do a dash T. We could try dash R though, and so it's going to look like this. We already have our CL20 inside of here though, so what we're going to do is we're just going to see that all this is blank. We're moving our 20 into our CL. So from here, it's going to be very similar to what we've done previously, so I'm just going to take this and I'm going to paste it right inside of here like this. That way we don't have to do as much work. So we have zeros here. We know our NV is 0, our NZ is 0, and our PL is 0. We have this and our address is 0F68. Our IP is going to be at 100. Our DS, if we just do a data dump. Oh, and we also have to change these values, right? So we're not at DS 200 anymore. Instead, we're at DS 554, and we're at DS 555. So if we data dump our values, I'll bring the I'll bring the notes here, and we are going to do this dump, and we see that we get our values 05 and 09. So inside of here, we're going to have the 05 and 09. And the reason why this didn't change is because right here, this column was already greater than this previous column, but that was for the previous part 1. So inside of here, we're changing this to be 5, and then we're changing this one to be 9. And then our next command, we're going to do the move. We're going to move CL to, or we're going to move 20. We're going to move the constant 20 to our CL. So that's going to be our code. Now we want the next thing, so we're just going to do a T, and that's going to bring us to the next part. And so for this next part, we note some differences in here. We're just going to copy all of this again because it's very similar. Our DX though is now, or not our DX, our CX is now 20. Our NV is the same, our NZ is the same, PL is still the same. This is still the same. We have added in 2 bits. Note that we are adding in the 20, which is just 2 bits, not like the 4 bits that we've done previously with the 120. Whenever we did anything like that, like if we go back here previously, and we had these values where we had like the values in here being 200 or 202, even though I believe they were slightly different for here, but if they were like this one, and we had the values in here, we would have to add like 4 here because this would be 4 bits or something like that. But in here, we're only doing 2 bits, so this is just going to move to 102. And we're still going to have 59 inside of here. Next, we're going to do another T, so this will give us the next thing. So I'm going to paste this one in here. We can see that our A of X is now 5, and our C of X is going to be 20. Our NV and Z and PL are still existence, and we know that we are now moving, well, we're moving 3 data up. So this is going to be 105. So that's because we've moved 3 bits. And we need to update these move instructions because I never did. So we're going to be moving into our AL register, which is the A low. We're going to be moving into this register our 0554. And then for this next one, it's going to be very similar, but we're going to be moving into our BL register. We're going to be moving into it our 0555. And that is going to be our moves. So we can do another T here, and our next value, we won't be surprised, it's going to be a 109. So for our 109, we're just going to paste the same thing in here. we're going to update some values. This is going to be 5, this will be 9, and this is going to be 20. D of x is still 0, and v is still here, and z is still here, pl is still here, this is still here, this is still here, but we want to change this to be 109. And let's do a data dump real quick, just to make sure our values are still what they are. So we're going to do d, and we're going to dump from 554 to 555. We can see that there's still the same values, so they've not updated yet. From here, what we're going to want is the next thing. And the next thing is where we have our t. That gives us a next part. So I'm going to copy all of this down because we should update it. Instead of moving here, I never updated this, but this is going to be, the next command is going to be sub al bl. So we're going to subtract bl from our a of l, and we're going to store it inside of our a of l. We're going to paste this inside of here. Our a is now going to be fc. We have 9 and we have 20. All of these values look to be the same, except for our pl. Our pl is different. You see our pl is an ng. And so if we are to look towards our lab report, there is a picture inside of here that will demonstrate what that is. So our pl is going to be, we know it's 0, and the difference now is that it's an ng, so it's a set. So if we go back here, we can see that this is just going to have to be updated from pl to ng, where we have a 1, so it's in the set state. And this is not going to be 109 anymore, it's going to be 0, but we don't have to include the 0. We'll just have 10b. And that is going to be our values. So now we have this next instruction where we're not moving, we're going to do jump greater than or equal to, and we have 0, 1, 1, 1. And that's just the point of where we are jumping. And we could see that if we were to unassemble our code again. Now, if we do our data dump here, D, and then we have 554 to 555, we still have 0509. Now we'll do T again, and we have another instruction here, very similar to what we've done previously, so we're just going to copy this line, paste it in here. FC 920, we have our NV, we have our NZ, we have our NG. This is now going to be a 10D. So I believe that's like a 2 or 4-bit add because we're going from B to D. And then from this one, we are going to have the next instruction, which is add AL CL. So CL is going to be added into our A of L, and what's going to be stored in our A of L. We'll do another data jump just to be sure. We still have the same values. We'll do a T. We're going to do a jump to 110B. So we paste this in here. We see that this is now updated to be 1C. We have 9, 20. We have an NV. We have, now this is a PL, so this is going to change back from an NG to a PL. We have this here. This is going to be 010F. We have 5. We have 9 still, if we were to run it. And then we have our jump. And then inside of our jump, we have our 010B. So that's our next instruction, and we're going to do a T. And then we have another jump greater than or equal to statement. So I'll just copy this one, and I'm just going to paste it right here. The only thing that is going to change is that we have our 1C here, 920, and V, and Z. We have our PL to be 0. This is going to be updated to be, 10B. So not updated, but it's going to be back here because we were doing a jump greater than or equal to. And now we're jump greater than or equal to 011. So we'll do a T here. Now we have a move command, which we did not have before. So it looks like we're making progress. We are going to move into our 0554 register, the value, which actually I should paste this right here. So we have 1C, we have 9, 20, NV, we have NZ, and we have PL. This address is going to be updated to be 0111. And then we have our values here. So we're not going to do a JGE. We're going to do a move into our 554 register, comma AL. And then what we're going to do is we'll test this. We'll do a data dump real quick just to make sure everything is okay. So we want D554, 555. We still have those values. We'll do T, and now we end our program. So we'll paste this down here. 1C, 920, and V, and Z, and PL. This is going to change to be 0, 114. We're not going to run it after our INT. And so our last instruction is INT 20. And that is the end for that. This can just be cleared because it's not relevant here. But this is going to be our tracing chart. If we do D554 and then 555, it has now updated. And so we have our 1C09. We saw that in the last video, and that was the equivalent of us just running this entire thing. The G is equal to a 100 is equivalent to running the, if we do the slash, or not the slash because the dash is already in there for us. If we do the R, and then we go on to the next line and we keep doing T's. So that's kind of the equivalent here. And so that is how we would get this to update and do our tracing chart.